is less than or equal to 42, and then is greater than or equal to negative 26. So you'd have 6 minus 32, which, as we saw before, is negative 26. So you have negative 26 is less than or equal to negative 26, which is less than or equal to 42. So both sides of this inequality is true. We know that negative 26 is equal to negative 26 over here. And we also know that negative 26 is a smaller number than 42. Likewise, if we were going to plug in a number from outside the range that we solve for, like 10, we would get negative 26 is less than or equal to 6 minus 4 times 10, which is less than or equal to 42. You'd have negative 26. That's going to be 6 minus 40 is negative 34, I believe. So we see that this actually isn't true because negative 34 is not greater than negative 26. It's a more negative number, so it's smaller. So any numbers that we plug into that expression outside of the number range that we solve for using the two equations that we did will give us incorrect answers or untrue statements. Was there any part of that that didn't make sense or that you want me to go back over?
Okay, so like if we divided negative 32 by negative 4, how come we didn't flip the sign?
Let me see.
Yeah, so I was thinking about that too. I remember having to flip the sign. So I looked at yeah, whenever we're dividing by a negative number, we should be flipping the sign, which is weird because when you solved for it, you got it to work out.
Right, that works out. I need to remember this then because I didn't have to do it just now. Let me see.
Yeah. Which is weird because you're right, Anastasia. You're supposed to flip the sign.
Yeah, give me just a second here.
Can you scroll up, Matt, back to what the problem originally was?
Yeah.
Oh, I think you would have to flip the sign because 8 isn't less than negative 9 in like your solution.
Mm-hmm.
Like that statement is incorrect.
Oh, yeah. See? Yeah, you're right.
Yeah.
Thinking backwards. 8 is greater than or equal to x, which is greater than or equal to negative 9.
Yeah.
That's my bad. That makes more sense. Because you can't have 8 be less than your number and your number is less than negative 9. Right. So yeah, you're exactly right. That's my bad. I missed that, but
no, it's okay. I forgot that rule too. I just remember there being a rule, and I just looked it up. I was like, there's something where you have to flip the sign.
Yep, you are exactly right. So whenever you do divide by the negative, yeah, we would need to flip both these signs in order to make that make sense. So this would be 8 is greater than or equal to x, and then x is greater than or equal to negative 9. Because you're right, this original answer didn't make any sense. But otherwise, the concept holds true where we did solve for the correct ranges. So whenever we plug in these values to the expression, they will work out to be true into the original expression. So that's my bad. Hopefully I didn't end up confusing you, but I think that we cleared that up. Does that make sense?
Yeah.
Okay. Yeah. So you're exactly right. We had the methodology right, but we missed flipping the sign whenever we divide by the negative number. Do we want to work through another one?
Okay.
All right, let me stop my screen share. All right. Is there any of these in particular that you want to do, or should we just, we can do number 11, or we can do any of them.
Let's see. Can we do number 8 and then this one would be good.
Which
Let
one?
me show you number 8. Okay.
Yeah, let me write that real quick. Alrighty, I got that one. And what was the other one?
Number 12.
For 12. All right, I got these written down. The handwriting is a little bit questionable, but I think we can decipher it as we go back through here. Let me share my screen again. Alrighty. So first we're going to do this one. 10 plus n over 9 is greater than 9. So we're going to solve this similarly to the others, where first we're going to divide 10 from both sides. So we get n over 9 is greater than negative 1. And then to cancel out this division, we're going to multiply both sides by 9. So we have n is greater than negative 9. So we know that n is anything greater than negative 9. So like if you look at our original expression, if we were to plug in negative 9, you would have 10 plus negative 9 divided by 9, which is negative 1. So it would be 10 minus 1, which is 9. And then that's not greater than 9 because it's anything greater than 9. So 9 equals 9. It'd need to be any number bigger. So any number greater than negative 9. So if you had like 10 plus negative 8 over 9, that'd be something like 9.1, which is greater than 9. And then you can pretty much go to infinity after that, where if you had 10 plus 900 over 9, it would be 10 plus 100, which is 110, which is greater than 9. So kind of like we did on the other ones, this one's actually a little bit easier because we don't have to solve for two sides. We just have to solve for one side of an inequality. So you solve it pretty much just like an algebraic expression. So then let's look at number 12. It looks like the easiest way to do this is first we're going to need to multiply everything out by each other and then combine some terms. So we have, first of all, we have negative 3x. And then we have minus 8 times 1 plus x. So what we want to do is we want to write out this part. So we're going to take negative 8 and we multiply it by 1. And then we also multiply it by x. And then we add them together. This is kind of like what we did with FOIL a long time ago, where it's a little bit simpler, but instead of having to do like first, outside, inside, last, we just have one number that we have to multiply against each of the two terms in the parentheses. So we'd have negative 3x minus 8 minus 8x greater than or equal to. So we do something kind of similar here where we have negative 7x minus 6. So this negative is just saying the same thing as negative 1. So we would multiply negative 1 by each of these terms. So you have negative 1 times 7x is going to be negative 7x. And then negative 1 times negative 6 is positive 6. And then plus 6. So then what we would do is we would combine all alike terms. So you'd have negative 11x based on negative 3x minus 8x minus 8 is greater than or equal to negative 7x plus 12. So then I want to get x to one side. So what I'm going to do is I'm going to add 11x to both sides. So that simplifies our inequality such that we show that negative 8 is greater than or equal to 4x plus 12. And then it's just like solving any other inequality, where we'll subtract 12 from both sides and get negative 20 greater than or equal to 4x. And negative 5 is greater than or equal to x. So the best way to do this, on these kinds of ones that are a little bit more complicated, a good thing to do is to check and see if it makes sense. So what I'm going to do first is I'm going to plug negative 5 into the original statement and see if it works. And then I'm going to pick something that's outside of the range and see if it doesn't work. There's my pointer. So we're going to take this negative 5 and we'll just plug this back into the original equation. So we have negative 3 times negative 5 minus 8 times 1 plus negative 5. I'm just going to go ahead and simplify that and make that negative 4. It's going to be greater to negative. Then we have 7x. I'm going to simplify that out. So 7 times negative 5 is minus 35. Minus 6 minus 41. And plus 6. So then what we would end up getting is 15 plus 32 is 47, which is greater than or equal to 47. Based on negative 1 times negative 41 is 41, so then 41 plus 6 is 47. So that's what we'd expect to see, is we'd want to see that whenever we solved out this inequality, both sides were equal to each other. So negative 5 is greater than or equal to x. Let's do an x that doesn't satisfy that and make sure it doesn't work. So let's say x is equal to negative 10. And the reason I picked that number is because negative 5 is greater than negative 10. So let's do 10. So negative 5 is not greater than 10. So we're going to plug 10 into our original inequality. So we're going to do negative 3 times 10 minus 8 times 11. I'm just going to kind of solve these out as I write them in to save us some time. It'll be negative, 64 plus 6. Now I can already tell you this is going to be negative 118 greater than or equal to like negative 58. Which is not true because negative 118 is a more negative number. And so anyway, if we were to go back into this equation and plug in negative 10 like I had before, which does satisfy this inequality, we would expect to see that whatever number we came up with on this side is greater than or equal to whatever number we came up with on that side. Did all my steps there make sense? And Eliza, did I miss anything? If you're watching, I don't know if you're watching, that's okay. But did that make sense? That one was a little longer.
Yeah, it was a little fast, but I think it makes sense to me. Does it make sense to you, Anastasia?
Yeah, that's what's important.
Yeah.
I understand the distributing part.
Uh-huh.
And then wait, what's this number? Negative 118 over what?
Oh, it's not over anything. So all that this was is I was just checking our answer. So
Okay.
first what I did, first whenever I did all the distributing and everything is I found our answer. And then for problems like this, especially like whenever you're getting started, if you have time on the test, I feel like it's a good idea to essentially make up some numbers and make sure your inequality works. So like our answer was -5 is greater than or equal to x. So what I wanted to show is like if we did -5 and we put it into the expression, it would work. And then if we picked a number that was outside of this range, I picked 10 arbitrarily because -5 isn't greater than 10 and plugged it in, then it wouldn't work. So what I was doing down here is I was just plugging in a random number to check our answer. Does that make sense?
Yeah, that makes sense now.
Okay, cool. I think we should probably just keep working through these since you have a full worksheet. Do you want to share another one?
Yeah, except for the word problems.
Let me open this up to you. Yeah, we can do a word problem too if you want to. I think you're the only one in the lesson, so we can just cover, if you have a test tomorrow, we'll just go over example questions.
At the bottom.
Okay. Let me figure out what's going on here real quick. Velocity. All right, so we have our velocity function, 20 minus 10 times t, where t is the time in seconds. At what time is the velocity between 10 and 15? So you would want to say...
Maybe snip it, Matt. Maybe
Yeah.
snip it while she has it on your screen.
Let's see. Let's see if I have snippet. I do have snippet. Oh, that worked wonderfully.
Yeah.
All right, that was a good idea. Let's go back to my screen. I'll do that from now on. That was really, yeah. Glad I can do that. Alrighty. So we have a problem here where we have a function that describes what our velocity is as a function in changing time. Where essentially if you throw a ball straight up, like you're going to throw it and it's going to go really fast, but then it's going to slow down, slow down, slow down, and then eventually the velocity is going to go negative whenever the ball starts coming back down to the ground. So here, like we're saying, whenever we throw the ball, at first it's going 20 meters per second. And then after 1 second, it's only going 10 meters per second. After 2 seconds, it stops. After 3 seconds, it's coming back down at -10 meters per second. And then after 4 seconds, it's going faster at -20 meters per second, kind of et cetera, et cetera, et cetera. So what we want to do is we want to find at what time the velocity is going to be between 10 meters per second and 15 meters per second. So we have our velocity is described by 20 minus 10t. So 10 and 15 are our ranges. So it says between 10 meters per second and 15 meters per second. So 10 is going to be less than or equal to our velocity, which is 10 minus or 20 minus 10x. And I said less than or equal to because it says, well, it says between 10 meters per second and 15 meters per second. So I'm actually going to say 10 is less than. And the reason I say that is because 10 meters per second isn't between 10 meters per second and 15 meters per second. So 10 is less than 20 minus 10x, which is going to be less than 15. So then to figure out this time range, we're going to solve this kind of like we did the other inequalities. So first we're going to do 10 is less than 20 minus 10x. So then negative 10 is less than negative 10x. And as we learned just a little bit ago, that means that 1 is greater than x whenever we solve that out. Swap the signs whenever we divide. So then we're going to solve this next side of the equation too. And I'll check and make sure we have the signs right here at the end. Subtract 20 from both sides. And then we flip the sign again. So x is greater than 0.5. So then what we're hoping we're going to see is that 0.5 is less than x, which is less than 1. So that means anytime between half a second and 1 second, the ball is going to be going between 10 meters per second and 15 meters per second. So we can plug in some values and check. So if I were to plug in, let's say 0.75 seconds, then it should be between this velocity range. So velocity is equal to 20 minus 10t. So here we're going to say that t is equal to 0.75 seconds. I picked that value because it's between the range that we saw for here. So then v equals 20 minus 7.5, which equals 12.5 meters per second, which is between 10 and 15. And now we're going to pick a number outside this range. So we're going to say 1.5 seconds. So we'll do v equals 20 minus 10 times t, which we're going to do 1.5 this time. So then velocity equals 5 meters per second. And as we saw in our original word problem, 5 meters per second isn't between the 10 and the 15 meters per second. So if we were to do something on the other side of this, like if we were to plug in 0, we would see that velocity is equal to 20 meters per second, which is also outside of our range. So the hitch with the word problem is being familiar with how these inequalities look and being able to read it and translate this into an inequality expression. Does that make sense? Did everything about that solution make sense, or was there anything that was confusing?
Yeah, I got my answer backwards.
Oh, did you flip the signs?
Well, no, it was just I got -1 is what's it called? Is less than t, and t is less than 0.5.
So I am willing to bet whenever you solve for that negative one, you were probably solving this part. You might have, let's see, you might have forgotten a negative sign somewhere, is probably what happened.
Oh,
So let's do this. Walk me through your process.
okay.
So we're solving this part, right?
Yes.
Alrighty. So what would you do first?
I draw a line between the sign.
A line between the sign.
Like in the middle of the sign, I drew the line. Helps me separate my problem.
Okay, I don't know which line. Not this line, right? Is there any, I'm gonna see if.
I think
any
she
way
just
you can draw this
means
out.
like a line down where like how you're looking at a regular equation, right?
Yeah, like a vertical line down the
To separate
middle
the
of the
sides. Yeah.
Okay. So we can draw the line. After you draw the line, what's your next step?
Wait, what happened to the 15?
We can put it here too.
Okay. And then next, next, I subtracted 20 on both sides.
Okay. So first we're gonna do 10 minus 20. And what does that give us?
10 minus 20, negative 10.
Exactly. I guess we can just do it this way, huh? And then what do we get over here?
We get negative 5.
Right. All right, so what's our next step?
Then I divided by negative 10.
Alrighty, so what's our answer over here?
It's going to be 1.
All right, and what's our sign?
Oh, it's going to flip. We flip the sign to less than.
And then what is our number and sign over here?
Yeah, we have to flip the sign again.
Mm-hmm.
And then it's going to be a
Hello?
0.5.
Hello?
Sorry, excuse me. Is this the free section for 7th graders?
Yes, this is. Hey, how's it going?
Oh, okay. All right.
So you're in the right place. Just to catch you up real quick, what we're talking about right now is solving inequalities. So we have about 15 minutes left in the lesson, but if you want to stay tuned in and watch how we go through some of these, and we'll be starting a new example pretty quick, and I'll be taking y'all how to go through that. So that might be helpful for you. But that's what we're working on right now. So anyway, we were wrapping up, Anastasia. We got this as our final answer.
Yeah.
Which was hopefully the same thing that we got before. And I think it was. I don't remember where I wrote it. Yeah, it is up here. So yeah, I think you were saying that you got like -1.
Yeah, I
somewhere.
messed up all my signs.
Yeah, you might have missed a sign somewhere. That's probably what happened.
Yeah.
Sweet.
Another thing you could do is make sure that it makes sense again, because -1 isn't greater than 0.5, right?
Yeah.
You write it out. So yeah.
Yeah, that's good advice. Kind of like either plugging in numbers to check it, or even just taking a step back and looking at your answer. What's really nice about inequalities is, especially two-sided inequalities, there's an easy sanity check to do there.
Yeah, if you have time, for sure, do both.
Yeah. All right. Well, we had someone else join in just now. What we're kind of doing is pretty much just working on homework problems and any general questions that y'all might have. So did you have any questions about anything that you've gone over in math or anything like that recently that
No,
we can talk about? Not in
no.
particular? Okay.
Yeah.
So I guess we can just keep going with inequalities then, because you might have a test on these soon too. So Anastasia, do you want to keep working through examples of inequality problems?
Okay.
All right, yeah, let's do that. I'll stop sharing my screen. Because I probably don't have time to start my lesson from the beginning at this point. So what I'll do is I'll just keep working from these. And some people that joined just now, feel free to cut in at any point if we're going too fast or if anything doesn't make sense.
Could we try like one of these?
Yeah. So let me just snip them all. So if I'm thinking through this right, these true or false might actually be a lot easier. Alrighty. I am ready. So first what we're going to be doing is we're going to be looking at these true or false questions with these inequalities. So let's start on the problem on the left here. We have p over -5 plus 12 is less than -4. And we want to see if 82 is a possible solution. So what we're going to do here is it's going to be the same process as we were using earlier to pretty much check our answer whenever we solve for what the inequality is. So what we're going to do is we're going to set p equal to 82 and see if the inequality is true. So whenever we plug that in, we get 82 over -5 plus 12 is less than -4. So then first we're going to subtract 12 from both sides. And I'm going to simplify this out too, because it's just easier for me to read it that way. So then we get -16.4, which it's the same thing as 82 over -5, but it's just dividing out the number and writing it as a decimal. And then we subtract from both sides. -4 minus 12 is -16. So we get -16.4 is less than -16. So we would say true, that's a possible solution. I'm gonna do one thing real quick. Likewise, what we could do is we could just pretend that we didn't know what p was, and we could figure out what values of p work for the inequality. So we have p over -5 plus 12 is less than -4. P over -5 is less than -16. And since we're multiplying both sides by a negative number, we flip the sign. So we get that p is greater than 80. So anything bigger than 80 would work. Our question is essentially, is 82 greater than 80? And the answer is yes. So if you have true or false questions like this, you can do it either way. I think it's probably a little bit easier to just look at the possible solution that they give you and plug it into the answer or plug it into the inequality and see if it makes sense. You can also solve the inequality and figure out what range of variables works and then compare your value to the one presented in the true or false question. So on this next one, I will go through and do it, or if there are any volunteers that want to give it a shot, let me know and I will work with you through the problem. So does anyone want to try to solve it themselves, or do y'all want me to solve it?
Can we solve it together?
Let's do it. All right. So you're up to bat. Here's our problem. What would you do first?
I look at the fraction first,
Okay.
and then I'd fill in r as -3.
All right. So I'm going to write that out for you. We're going to have -3 minus 2 over -4 is greater than 4 times -3 minus 12. So then I'll give you just a second. We're going to solve these out one at a time. What number do you solve this out to be on the left side? You can leave it as a fraction or a decimal or however you're the most comfortable. Mixed number.
I think, okay, I'll distribute.
Let's see. So you mean you'd pull out the negative sign? Is that what you're referring to, where you'd do -3 plus 2 over -4? Is that what you're referring to?
No. I like distribute the 4 into like -3.
Oh, I see what you're saying. So you're going to do -3 over -4 like that, plus -2 over -4. Is that what you're saying?
No.
Are you talking about the other side of the equation?
Yes.
Okay.
Oh, okay. You're on the other side than me. All right. So we're going to start over here. So if we distribute the 4 into this 3, you get -12, -12. All right. That's what you were doing, right?
And wouldn't you be able to like combine it?
Yep. So you get -24. And what do you get on the other side of the equation?
Okay. It'd still be the same.
So yeah, what I'm going to do is I'm just going to simplify this out. We're going to have
Really?
-5 over -4. And then that would be 1.25.
Why would
Does
you
that make
have
sense?
why would you have a fraction?
So whenever I plugged in -3, so on this one, both sides of the inequality have the same variable. So there's an r on the left and an r on the right. So whenever I plugged in that -3, I substituted this r with a -3 and this r on the right with a -3.
Okay.
Does that make sense? Because basically both sides of the inequality have the same variable. So we have to plug in the value that we're testing into the variable on both sides.
Yes. I mean, I can see why you simplified it into a decimal.
Oh yeah, I just did that because it's easier for me to look at, but you don't have to. I mean, just however you simplify it or write it out, or at whatever point, like if you see that 5/4 is greater than -24, that's fine too. It's a personal preference for me to use decimals. I kind of just like do it automatically because like that's easier for me than fractions. But if you want to leave it as fractions, it's the same thing and it's also correct. So anyway, let me see. Our original question was -3 is a possible solution. So we plugged in -3, and whenever we solved the inequality, we got that 1.25 is greater than -24, which is true. So the answer is true. -3 is a possible solution to this inequality. So rather than solve that out, I'm going to move on to another question that I'm probably going to have to rewrite because I've made such a mess. So we're going to have something kind of similar. So we have another inequality that they've given us, and we have 3 numbers, and we want to determine which one is a possible solution. So they gave us -74, -75, and -76. So there's 2 ways that we could do this. The first way would be to do y equals -74, and then do y equals -75, and then do y equals -76, like we did with the other true or false problems, and see which one works out.
Hello.
Or, hey, how's it going? Welcome. Thanks for coming. You're kind of hopping in at the tail end here. You're going to have time to see a quick example of an inequality problem. What we're doing is we are solving inequalities, which is similar to solving simple algebraic problems. So anyway, going back to our example, we were given an inequality expression. 12 is greater than -2/5 times y minus 18. And we were given 3 numbers, -74, -75, and -76. And we were tasked with finding out which of these numbers works. So rather than plug them all in individually, what I'm going to do is I'm going to solve this inequality. So we're going to do 12 is greater than -2/5 y. We're going to add 18 to both sides. So I'm going to add 18 and cancel this out. Add 18, we're going to get 30. So we're going to get 30 is greater than -2/5 y. And to simplify this, we're going to divide both sides by -2/5. And whenever you divide by a fraction, what you do is you multiply by the reciprocal, which is a fancy way of saying you flip it over and multiply it. Let me see. Yeah, this is going to be the last example I do, so I'm going to be done pretty quick here. So then we multiply both sides by -5/2, and we flip the sign. So we're going to end up with negative 150 over 2 is less than